Mithun, you have joined from a different device?
No, my network is very poor.
Okay, okay. So should I start now? All of you ready? Suleiman ready?
Yes, ma'am.
Fine. So we were discussing about the atom, and I gave you the context for this chapter. The context for this chapter is, I'll quickly revise those points, okay? And let me just quickly tell you that this chapter, along with the third chapter, they are the fundamentals of chemistry. So please, my advice and suggestion would be to all of you would be take this chapter very seriously. Try to understand the chapter conceptually properly, okay? And then try to understand, then try to apply it. Fine. So in the third chapter, we learned about the atom. We tried to understand about the atom. We saw how is the atom existing. First, we established that atom is the smallest participant of the chemical reaction. In a chemical reaction, it is the atom which is basically participating from the element side, right? That is something that we have established in the third chapter. After studying that, we were able to study the shape, the size, the symbols, and the atomic mass of the atom, right? Atomic mass of the atom. And also after that, we were able to understand how does the atom really exist. So it does not exist just as one atom, but rather it exists as a group of atoms, right? And that we call as a molecule. Now the molecule could be elemental or the molecule could be compound, right? The molecule could be in the element form or the molecule could be in the compound form. That's a different thing. But atom is existing in the combined form, not as one single individual atom. Other than the molecular form, what's the other form in which atom exists? That was the ion. That was the ionic form, right? Cations and the anions. So cations and anions, when they are existing, how do they bond? They bond through the formation of the ionic bond that we have seen. So ionic compounds we have seen, sodium chloride, calcium chloride, all of these are what? Ionic bonds, right? Ionic compounds. And once we know the formula, once we know the molecule, whether it's an elemental molecule, whether it's a compound molecule, whether it's ionic molecule, ionic compound, we can calculate the molecular mass. So all of that has been discussed in the third chapter. What is it that we are going to learn about or try to understand in the fourth chapter? We are going to deep dive in the atom. What is it in the atom that is giving different properties to the atom, to different atoms? What is it that is making metals as cations and non-metals as anions? What is it that is making atoms, some of the atoms as cations, other atoms as anions, right? So what is that thing that is basically driving the atom to behave in different manners? And for that to be understood, we need to understand what is exactly inside the atom. What is inside the atom? What is the arrangement of these particles like inside the atom? So we started with this thing, and see, we have two important topics in this chapter. First is the different, models given for the atom in respective years as we progress, and then we have how the subatomic particles are arranged in the atom. So I'm taking the second part first, and then we'll move on to the first part. Okay. So in the atom, how many different subatomic particles do we have? How many different subatomic particles do we have?
Three, ma'am.
Three. What do we mean by subatomic particles? Now we have deep dived into the atom. So there are three different particles present within the atom. That means subatomic particles, namely electron, proton, and neutron. And we'll be understanding each and everything related to these three different particles so that we are able to understand different behaviors of the atom, right? Fine. So electron, proton, neutron. What is the charge like? What is the charge on electron? What is the charge on one electron?
Negative, ma'am.
Minus 1e, right? Negative e.
Yeah, ma'am.
Minus 1e. And what is this e? What is this e? This is the elementary charge. What is this? Elementary charge. Huh? What is the value for this? What's the value for this, bacho? Lokya, can you tell me if I have given you the value of the elementary charge, which I have given you on the screen, can you tell me the charge, proper charge on one electron? What will be the charge on one electron?
1.6 into 10 raised to negative
19. Minus 1.6 into 10 raised to the power minus 19 coulomb. Huh? For one proton, what will that be? For one proton, what will that be? Plus 1e, right? and that makes it plus 1.6 positive 1.6 into 10 raised to the power minus 19 coulomb. What is coulomb here? Method, what is coulomb indicating here? Bethel has joined. Okay. Method, what is coulomb indicating here?
What, ma'am?
What does coulomb indicate here, bache? This coulomb.
I don't know.
Bethel, what does coulomb indicate here?
Ma'am, I don't get you.
Bethel, what does coulomb indicate here? What is coulomb indicating here? Why we are writing coulomb with the elementary charge value? Lokya, what is this indicating here? Coulomb. Nikhil, what does this indicate here, bache? Coulomb.
Ma'am, standard unit of electric charge.
Excellent. Standard unit of charge. Okay.
Okay.
Standard unit of charge. So definitely we are measuring the charge here on one electron and one proton. What will be the unit that we'll be using? The standard unit of charge, that is coulomb. Okay. So therefore, coulomb is the standard unit of charge. Very well said. Fine. The second thing is that so electron is negatively charged, proton is positively charged, and the neutron is neutral. That means it has no charge. Okay, it has no charge. Come on to the next property, that is mass. Electron, you can see, is really small in mass compared to the mass of the proton and the neutron, whereas the mass of the proton and the neutron were almost similar, right? They are almost similar. So 9.11 into 10 raised to the power minus 31 kg. Why kg? Again, the standard unit of mass is kg. Okay, the standard unit of mass is kg. Now, minus 27, minus 27. Fine. Very important location. Where are these different subatomic particles found? Where? Within the atom. We are trying to understand the structure which is within the atom. So where are these subatomic particles found within the atom? The proton and the neutron together are found in the nucleus. Whereas the electrons are found on the shells or the orbits. Anyone, any problem till here? Please let me know. I've just revised whatever we discussed in the last class. Suleiman, is it clear to you, bache?
Yes.
Fine. Moving on to the next point, very important. So the atom is overall neutral. What does that mean? Overall neutral, it has charges in the form of electrons and protons, but overall it is neutral. That means it does not have any net charge. Its net charge is zero. Okay, that is, it is neutral. Its net charge is zero. Now, if the atom is overall neutral, what does that indicate? What does that indicate? That indicates if there are positive charges and negative charges, there should be equal number of positive and negative charges which are able to neutralize each other, right? Which are able to neutralize each other. Yes or no? No answer, no? Bethel, camera on. Fine. I'll continue here. So when the atom is overall neutral, that means equal number of negative and equal number of positive charges should be there. When equal number of positive and negative charges are there, that means the number of electrons and protons are equal in the atom. Why? Because the charge on one electron is equal but opposite to the charge on one proton. The charge on one electron is equal but opposite to the charge on one proton. Therefore, in an atom which is overall neutral, the atom will have equal number of electrons and equal number of protons. Is it clear?
If you don't mind, can you revise the topic once more?
Sorry?
Can you? I said that. Can you revise that? Like, can you say it again?
Not audible. Can you revise?
Can, if you don't mind, can you say the whole topic again? Like, can you revise about the whole topic again?
Mithun, why?
Because I was focused on I was focused on fixing the network problem and all. Because even I couldn't hear in the mobile also. It was echoing.
Just 1 second. Very quickly. There are three subatomic particles within the atom, okay? Electrons, protons, and neutrons. Now we are going to learn some of the different characteristics for each of the subatomic particles, okay? Why? Because these are going to affect the nature of the atom, the behavior of the atom. So that based on the charges, the electrons are negatively charged, -1e, okay? Protons positively charged, +1e, and the neutrons are neutral, okay? Neutrons are neutral. Mass, the mass of electron is into 10 raised to the power -31 kg, whereas the mass of proton and neutron, they are into 10 raised to the power -27 kg. So the mass of electron is very, very, very small in comparison to the mass of the proton and the neutron, whereas the mass of the proton and the neutron, they are almost equal. Okay, they are almost very similar. Whereas the location within the atom, where are these subatomic particles present within the atom? The proton and the neutron are together present inside the nucleus of the atom. Okay, that together present inside the nucleus of the atom, whereas the electrons are present on the orbits or the shells of the atom. And we will learn where are these situated, where is the nucleus, where are the orbits. But as of now, just know that the protons and the neutrons are present inside the nucleus, whereas the electrons are present on the shells or the orbits. Clear? Fine. The next part. The atom is overall neutral. The atom is overall neutral. It has different charges in the form of electrons and protons, but overall the atom is neutral. Overall the atom is neutral. And why is that? See, the charge on electron and proton, one electron and one proton, it is equal but opposite. So therefore, if the atom is neutral, that indicates that the number of electrons in an atom should be equal to the number of protons in an atom. That is why it is coming overall as neutral. Fine. Now see the next part. The next part. How do we know the number of electrons and protons and the neutrons in an atom? How do we know the number of electrons, protons, and the neutrons in an atom? See, I will quickly draw it here, please. See, this is the nucleus of the atom, which is at the center of the atom. Okay. And what does this have? It has the neutrons and the protons. It has the neutrons and the protons. Then we have the shells which are present around the nucleus. The shells which are present around the nucleus, and on these shells we have the electrons. On these shells, we have the electrons. Is the structure clear like this to everyone? Bethel, stop yawning. Is
Yeah,
this
ma'am.
clear to everyone? All of you? Fine. Now see, the neutrons and the protons are together called as the nucleons. Are together called as the nucleons. Why are they together called as the nucleons? Because both of them are present in the nucleus. Therefore, together they will be referred to as nucleons. If I'm referring to nucleons, that means I'm referring to both the neutrons and the electrons
And the protons.
and the protons. Good. Fine. Now see, how do we know the number of electrons, protons in an atom? Electrons, protons, and neutrons in an atom. See, very, very, very important. We have atomic number for an atom. Okay. Atomic number for an atom represented by Z. Okay. This tells the number of atoms, number of protons in an atom. Number of protons in an atom. Okay. Number of protons in an atom. And always remember, atomic number is like an identity card for the atom. Okay, for the atom. And why am I saying this? Listen very carefully. Let's suppose Bethel and Nokia are two atoms. Okay, if their atomic number is same, if both of them are having same atomic number, that means they are same type of atoms. That means they are same type of atoms. But if they are having different atomic number, that means they are different atoms. Okay, that means they are different atoms. Therefore, it is the atomic number which will decide whether the atom is same or not. Is that fine to everyone? Therefore, can you tell me, Bethel, that in case of elements, will all the atoms have same atomic number in case of elements?
No.
Why? Hmm.
Because every element.
I'm asking in case of elements, let's suppose we are taking one element, and in that element,
Yes, ma'am.
good. In one element, all the atoms are same, right? Therefore, all the atoms will have the same atomic number. Okay. Therefore, we say that the atomic number for an element. Why for an element? Because all the atoms of that element is having they are having the same atomic number. Therefore, we also say the atomic number for the element. Fine. Good. As you were saying the symbol of the element, right? The atomic mass of the elements, right? So all of that is basically referring to the elements because all the atoms for one particular element will be same and all their properties are same. Mass, size, symbol, the atomic number, all of that is same. Fine. Therefore, so through this we can get to know the atomic number. Through the atomic number of the atom, we can get to know the number of protons in an atom. Fine. Now see, do we not know that the number of protons in an atom should be equal to what? Number of electrons, right? Yes or no? Right. Therefore, I can say it like this. Please pay attention. Z equal to number of protons, which is further equal to number of electron. Yes or no? Electron, we represent it like this, okay? E with a negative charge. Is this understood to both all of you?
Yes.
Fine.
Yes.
Suleiman, clear? Fine. Question. Z for an atom is equal to 12. Tell me the number of protons and electrons in this atom. The number of electrons and the protons in this atom.
Ma'am, number of electrons is 12, right?
Okay. And proton?
Proton is like Z is, so proton is also will be 12.
Sorry?
Proton will also be 12.
Yes, proton will also be 12. Okay. Proton will also be 12. Therefore, the number of electrons, see, we know that the number of electrons and protons in an atom are equal. So Z is equal to 12, which is number of protons, right? Which is further equal to number of electrons. So therefore, it is also 12. Clear? Everyone clear? Fine. Now coming on to the very important part, that is next, the mass number. The mass number. We denote the mass number for an atom by A. We denote the mass number for an atom by A. See, the mass number of an atom tells you total number of nucleons. I've written nucleons. And therefore, can I write neutrons plus protons? Nucleons is nothing but neutrons and protons, right? Together. And why are we saying this? See, please pay attention. We know that the atom has, let's suppose an atom has 5 protons, 5 electrons, and 10 neutrons. Okay, please pay attention. An atom has 5 electrons, 5 protons, and 10 neutrons. How will we calculate the total mass of the atom? We will add the mass of the 5 protons, we will add the mass of the 5 electrons, and then we will add the mass of 10 neutrons. All of you agree with this? That is what
Yes.
we are going to do. Fine. But then we know the mass of one electron is very, 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 very small in comparison to the mass of one proton and neutron. Almost it is negligible. Therefore, we will not be taking the mass of the electron. Therefore, we will not be taking the mass of the electron. So what are we basically doing to find the mass of the atom? We are just calculating the mass of all the nucleons present inside the atom. Yes or no? We are just taking all the nucleons and we are taking that mass to get the mass of the atom. Yes or no? Therefore, the mass of the atom is coming from the nucleus of the atom. The mass of the atom is coming from the nucleus of the atom. All of you agree with this? Therefore, the mass number tells you the number of nucleons. Why the number of nucleons? Because the more the number of nucleons will affect the atomic mass. Yes, the number of nucleons will affect the atomic mass. Bethel is done with it, huh? Bethel, let's come to the question. See, always remember, how do we represent it? See, let's suppose we have any symbol of the element. Okay, Z will be written here and A will be written here. Z will be written here and A will be written here in the subscript. Now see here. Question. Tell me what element is this? Tell me the number of electrons, tell me the number of protons, and tell me the number of neutrons. All of you, quickly. Lokya, Nikhil, camera on. All of you, quickly. Ji, done? Just 1 second. Sorry for the mistake. I've written it oppositely. Sorry for my mistake, yes. A will be on the top side and Z will be in the bottom side. Fine. Now, how's the Diwali going, all of you? Mithun, Nikhil, huh? Good?
It was good, ma'am.
Good. Ji, done?
Ma'am,
Yes.
will it be like 11, 11, 12?
Mithun, I'm not able to understand you. Could you please repeat it clearly?
Wait. It will be like 11, 11 and 12.
Okay. Number of protons 11, number of electrons 12.
Yeah.
Electrons 12,
Yes,
huh?
ma'am.
No.
Huh.
Protons 11 and electrons it's I think it's 11. Electrons is 11 and neutron is 12.
12. All of you got the same answer?
Yes,
Or
ma'am.
has anyone gotten a different answer? Lokya got the same answer? Fine. Suleiman, you got the same answer, bacha?
Yes, ma'am.
Fine. Bethel? Nikhil?
Yes, ma'am.
See, good. Yes, done. Very good. Very good. See, I'm going to solve it here. We know this is indicating the number of protons, right? This is indicating the number of electrons. Why? Because 11 here is the value of the atomic number. An atomic number for an atom is nothing but the number of protons present inside the atom, present in the atom, and which is further equal to the number of electrons. Now come on to the 23. What is this 23? This is the mass number. And what does this indicate? The neutrons plus protons. We know the number of neutrons is what? What is the number of neutrons here?
The number of neutrons
11.
are 11.
Therefore, neutrons will give us, neutrons will be 12. Okay, good, well done. Fine. Acha, how are we getting to know this A? I'll give you one question and all of you will solve it. And please be honest. Tell me the number of neutrons, protons, and neutrons here, and I have not given the value of the mass number here. I have not given the value of mass number here. Okay. All of you will tell me the value of the mass number for this. What's this symbol? What is the element with this symbol?
Aluminium.
Aluminium. Good. So what should be the mass
Aluminium.
number for the aluminium? Good. Yes. What should be the mass number for aluminium?
It is
Atomic mass.
Very good. The atomic mass will be taken as the mass number here. Because what is the atomic mass?
ma'am, like
Atomic mass is coming from the mass number, right? Yes. So therefore, here the value of A will be, bacho, what will it be? 27. Okay, good, Suleiman. It should be 27. Now you know it. Quickly calculate the number of neutrons, protons, and electrons. I've written it twice. Very quickly, all of you. Nikhil will tell me the answer first. Okay. Ji, done. Look here, has done it. Yes, look here. Electrons.
Ma'am, electrons are 13.
Protons.
13.
Bethyl
Neutrons are
neutrons.
14.
Okay.
Neutron
Bethyl neutrons number
14.
No, are you asking me?
14.
14. Okay. Fine. All of you got the same answer?
Yes,
Nikhil,
ma'am.
you got the
Yeah,
same
ma'am,
answer?
yeah, ma'am, it's
14.
14. Neutron is 14.
Yes.
I was 40.
Neutrons is 14. Yes, good. All of you good. And everyone has understood this. Any problem here to anyone?
No, ma'am.
No. And see, all the atoms of the aluminium element will have the same atomic number. All the atoms of the aluminium element will have the same atomic number, right? Listen, am I not clearly audible? Is my network having some problem?
No, ma'am.
Fine.
Yeah.
Fine. That's now see what we are moving on to next is very important point, and that is now once we have understood what is present inside the atom, there are electrons, protons, and neutrons. We know how to calculate the different number of neutrons, protons, and electrons present in a particular atom. Now, how are they arranged? In what manner are they arranged? That is what we are going to understand now. Fine. So see, where are the arrangement? Where are the neutrons and the protons present inside the atom? Where are the neutrons present inside the atom?
Nucleus.
They are present in the nucleus, and
Nucleus, right?
the
Nucleons.
near the
therefore,
shell, the electrons are present.
okay, they are present in the nucleus. The electrons are present on the shells, on the shells of the orbit, and that is where the difference comes. See, very important, very important. Let's suppose we have one nucleon. That is, let's suppose the total number of neutrons and protons is 1. That will be present in the same nucleus, which is present at the center of the atom. Let's suppose we have 100 nucleons, okay? 100 nucleons. Yet all of them will be present in the same nucleus, which is there at the center of the atom. Yes. Therefore, whatever number of neutrons and protons is there, whatever number of nucleons we have, all of them will have to be present in the same nucleus. All of them will have to be present in the same nucleus, which is at the center of the atom. There is one nucleus of the atom, which is at the center of the atom. But the electrons which are present on the shells, we have not one shell, but many shells. And what does it depend on? The number of shells. See, each shell has a maximum capacity of the electrons that it can have. Each shell has a maximum capacity of the electrons that it can have. Okay. Therefore, based on the total number of electrons, the number of shells will be different. Based on the total number of electrons, the number of shells will be different. And what is that called as? Please pay attention. That is called as electronic configuration. Electronic configuration. Mithun and Nikhil. Let's suppose both of you are different atoms, okay? Both of you are different atoms, okay? Mithun, you have 20 nucleons, okay? And Nikhil, you have 21 nucleons, fine? Nikhil, you have 21 nucleons, and Mithun, you have 20 nucleons, fine? Now, for Mithun and Nikhil, all of the nucleons for each of you will be present in the same nucleus, right? Will be present in the same nucleus. There is no different arrangement of the nucleons in the atom. But Mithun, if you are having, let's suppose 10 electrons, and Nikhil, if you are having, let's suppose 17 electrons, don't you think the arrangement will be different? Don't you think the arrangement will be different, yes or no?
Yes, ma'am.
Therefore, in an atom, what is causing the difference mainly? It is the arrangement of electrons. It is the arrangement of electrons which is mainly giving you a character, a different characteristic to the atom. Is that clear? And we'll see by the example. See, what is electronic configuration? Arrangement of electrons on the shells. These are also called as electronic shells, okay? Electronic shells and orbits. And why are they different? Because each shell has a maximum capacity. Each shell has a maximum capacity. Let's quickly see the maximum capacities here, okay? See, please pay attention. The maximum number of electrons in each shell is given by this formula. What is n? The number of shell. The number of shell. Let us suppose we are talking about the second shell of the atom. We are talking about the second shell of the atom. So what will be the maximum number of electrons in the second shell of the atom? Don't you think it will be like this? And what does this give you? 8 electrons, right? Yes or no? Suleiman, is it clear, bache?
Yes.
Lokya clear? Bethel clear?
Yes, ma'am.
Fine. So the maximum number of electrons is given by what formula? 2n square. So therefore, the first shell, what will be the value of n here? Will be 1. And what is the maximum number of electrons here? 2. Okay. 2 electrons are the maximum for the first shell. And this shell is also called as the K shell. Okay. This shell is called as the K shell. This shell is closest to the nucleus. This shell is closest to the nucleus as it is the first shell. Bethel. Too boring, huh?
Ma'am.
Too boring. Too boring. N is equal to 2. For the second shell, but you see here, for the second shell, N will be equal to 2, right? And what will be the maximum of number of electrons? Can you tell me? 2n square? 2n square will give us 8.
4D.
We just now, huh? Who is answering and what is answered? So it will be 8 electrons. The maximum number of electrons that would be present in the second shell is 8. Let's come to the third shell. What will be the value of n here? What will be the value of n here?
Ma'am, 3.
3. What could be the maximum number of electrons present in this shell? All of you.
18.
18. Okay. And this is called as the M shell. And we keep on moving to the next shells, fine. But see, the important part here, bacho, we will just be considering the first 20 elements. First 20 elements. And for the first 20 elements, bacho, the maximum number of electrons in the third shell, okay, is also 8. Please know this. As we'll move on to the next series of the elements, that is from the 21st element to the next subsequent elements, the maximum number of electrons that could be present in the third shell will be 18. But if you are restricted to the first 20 elements, the maximum number of electrons that could be present in the third shell is 8 electrons. Is it fine, all of you? Fine, yes or no? Now quickly, next example. All of you have written this? Is anyone writing this? So respond.
I wrote it.
Look here, written.
Yes, ma'am, written.
Nikhil. Nikhil, done?
Ma'am, can you scroll up?
Yes, I can. But you just let me know that, okay? I'm asking you continuously for this thing.
Uh, yeah, ma'am, done.
That Suleiman done? Fine. See. Quickly, all of you will tell me this thing. Quickly tell me the electronic configuration for this. Very quickly, all of you. Along with that, you will tell me the number of electrons, the protons, and the neutrons in this atom. Very quickly. Why does the camera get shut down, huh? Haji, Nikhil, how many protons in this atom?
Ma'am, 8.
8. How many electrons in this atom?
8, ma'am.
8. How many neutrons?
9.
Huh? 16 minus 8 gives you 8, huh? Fine. 8.
Oh, okay, ma'am. Sorry.
Okay, no worries. No worries. See, now what is our main concern? Protons and neutrons, whatever number of protons and neutrons we have, they will be present in the same one nucleus which is at the center of the atom. What is our concern? What is our concern? The arrangement of electrons, right? Arrangement of electrons. So how many electrons we have? 8 electrons. Out of these 8 electrons, 2 of them can be there in the first shell. 2 of them will be present in the first shell, yes or no? Please say yes or no.
Yes, ma'am.
Yes. So 2 we make it in the first shell. Still how many electrons we are left with?
Ma'am, 6.
Do we need to move to the second shell? Because we are still left with 6 electrons and the maximum capacity of the first shell is 2, right? So we definitely need to move to the second shell.
Yeah.
So how many electrons are we left with? 6. What is the maximum capacity of the second shell?
8, ma'am.
8. So can I really fill all the 6 electrons in the second shell?
Yes, ma'am.
So I get the electronic configuration for oxygen as 2 and 6. 2 electrons in the first shell and 6 electrons in the
Second shell,
second
ma'am.
shell. Is this clear to all of you? Clear to all
Yeah,
of
ma'am.
you? We'll take one more
Yeah.
example. We'll take one more example. Let's say the fluorine. Let's take the example for sodium. Sodium was 23 and 11. Okay. How many electrons are present in this atom?
Ma'am, 11.
11 electrons. Let's quickly have the electronic configuration for this. 2 in the first shell. Yes or no? 2 in the first shell.
Yes,
How
ma'am.
many electrons are we left with now?
9, ma'am.
9. So do we need to move to the second shell here?
Yes, ma'am.
9. So what is the maximum capacity of the second shell, bacho?
8, ma'am.
8. So out of the 9, can I fill 8 in the second shell?
Yes,
Still I'm
ma'am.
left with 1 electron. Yes or no? Still I'm left with 1
Yes,
electron.
ma'am.
So can I move to the third shell? Yes, I need to move to the
Yes,
third shell
ma'am.
and I can fill the remaining 1 electron in the third shell.
Yes, ma'am.
Anyone, any confusion here, please let me know. Suleiman, Lokia, Mithun, is it clear? Suleiman,
Ma'am,
Yeah, ma'am.
clear?
Yes,
can
ma'am.
you please say it
Fine.
again?
Mithun, I'm not able to hear you, bache.
Can you just say it again? The
Yes, I
network
can
is.
definitely say it again. Fine. See, the electrons are present in the shells. And the shells have a maximum capacity and that affects the arrangement of the electrons, right? Now, based on the total number of electrons, we will have different arrangement of the electrons in the different shells. Based on total number of different, like the total number of electrons, we will have different arrangement of the electrons, right? So let's say we have 8 electrons for oxygen atom. So since we have 8 electrons in the oxygen atom, 2 of them will be present in the first shell because the first shell has a maximum capacity of 2 electrons. Yes or no? Yes. We are still left with 6 electrons. We'll move to the second shell. The second shell has a maximum capacity of 8 electrons. So definitely we can have the 6 electrons present in the second shell. See, we can have the 6 electrons present in the second shell. Fine. Now coming on to the next example that we have taken is for sodium. Sodium has 11 electrons. So 2 in the first shell, 8 in the second shell. Still we are left with 1 electron. So we'll fill the 1 electron in the third shell. Is it fine, method? Okay. Quickly tell me for aluminium, which has the atomic number as 11. Quickly tell me the electronic configuration for aluminium, all of you.
1, ma'am.
No one will answer. I will ask someone and that person will answer.
Ma'am, since aluminum it is not given a mass for aluminum, we can take the atomic mass as 26, right?
What is the need of having the mass number here for aluminium if I'm asking for the electronic configuration?
So we don't have to find the proton, neutron, and all?
Let's see if you can find it from the given information.
Okay, ma'am.
Yes, look here. What's the electronic configuration here for aluminium? How many total?
2,
Hmm.
2, 8, and 3.
And I've written as 11, and that is wrong, and it is 30. Good. 2, 8, and 3. 2,
Yes,
8,
ma'am.
and 3. Now, what I'm trying to tell you here, see, these sodium, aluminium, oxygen, these are different elements. These are different elements. Okay. And their atoms have different atomic number then. I mean, the atoms of sodium, the atoms of oxygen, the atoms of aluminium will have different atomic number. And if they have different atomic number, they will have different number of protons. If they have different number of protons, they will have different number of electrons. And if they have different number of electrons, it is very, very, very obvious that their electronic configuration will definitely be different. Yes. And we'll see what is the effect of the electronic configuration. But as of now, just understand if they are different elements, they will have different electronic configuration. Why? Because they're different atoms. They have different atomic numbers. They have different number of protons, and therefore they have different number of electrons. And if they have different number of electrons, the electronic configuration is different. Yes or no? Tell me the electronic configuration for nitrogen, which has the atomic number as 7. Quickly, all of you.
Ma'am, 2, 5.
Done, ma'am.
What is it?
Ma'am, it's 2.
Huh?
Then it is 6.
5, huh?
No, 5, 5, 5.
5.
Yes.
Good.
5.
So 2 and 5. That's the electronic configuration for nitrogen. And if you compare it with that of oxygen, the oxygen, I'm writing it here, was what? 2 and 6, right? These are different elements. The electronic configuration is clearly different. No same element will have the same electronic configuration. Okay. I mean, no two elements will have the same electronic configuration. Is that clear to each and every one of you?
Yeah, ma'am.
Fine.
Yes, ma'am.
Fine. Now, moving on to the next one. So the first 20 elements, I'm writing all the elements here. You will tell me the electronic configuration very quickly. Fine. So the first 20 elements. And please know that the elements are arranged in the periodic table on the basis of their atomic number, in the order of their atomic number. So the first 20 elements will have their atomic numbers as 1, 2, 3, 4, 5, 6. Okay. The first element is hydrogen. The first element is hydrogen. What should be the atomic number here?
Ma'am, 1.
1. And if the atomic number is 1, what should be the electronic configuration?
Ma'am, 1.
1. 1 in which shell?
First shell, ma'am.
First shell. Clear to all of you? Then only I'll move to the next element. Please respond. Clear? Fine with everyone?
Yes, ma'am.
Fine. The second element is helium. What should be the atomic number?
2, ma'am.
2. What should be the electronic configuration,
2.
Bache?
2, ma'am.
2. Good. We don't really need
2,
to
ma'am.
move to the third shell, right? There's no need for moving to the third shell. We have 2 electrons. All of those 2 electrons could be present in the first shell itself, okay? The third one is lithium.
3,
The
ma'am.
atomic, yes. Suleiman, please go ahead, Bache. Yes.
So,
Ma'am, just my
I'm 2, 1.
Mithun, just a second. Mithun, just wait for a minute. Yes, Suleiman, go ahead with your question.
ma'am, just now you said helium. This I cannot say this number. That equal to 2. So, ma'am, you
Uh-huh.
said atomic mass, right?
Atomic number, Bache. Atomic number. This is the atomic number. See, please see this. No worries. A very good question. The point is, we are basically concerned with the electronic configuration. And why are we concerned with the electronic configuration? Because different elements, different atoms will definitely have different electronic configuration. Why will they have different electronic configuration? Because they have different atomic number. They have different atomic number. Therefore, for the electronic configuration of the atom, we need the atomic number of the atom. Okay? We need the atomic number of the atom. Here for helium, we have the atomic number as 2. Right? We have the atomic number as 2. Therefore, the number of protons in helium is 2. And for that reason, the number of electrons in the helium will also be 2. And if we have 2 electrons in the helium atom, in what manner will they be arranged? So both of the electrons will be present in the first shell itself because the maximum capacity of the first shell is 2. Is it clear?
Okay.
Is it clear, Suleiman, 100%?
Yeah, ma'am, yeah.
Fine. Now, lithium. Tell me the electronic configuration. The atomic number will be 3.
3.
What should be the electronic configuration? Bethel.
2.
2 and 1.
2 and 1. The fourth is beryllium.
4.
Hmm.
Ma'am,
Quickly.
2 and 2. 2 and 2.
2 and 2. Boron.
5, ma'am.
5. 2 and 3.
2 and 3.
Carbon.
Carbon.
Yes, yes.
Two,
Just a second,
2
all
and
of
4.
you.
2 and 4.
Wait. All of you wait. Yes, Suleiman.
Ma'am,
Hmm.
ma'am, we can add this one. We can add in boron. We can write 3 and 2, right? Or 2
No.
or 3.
2 and 3. But we are writing this in on the basis of the order of the shell, right? The first shell can only have 2 electrons. The first shell cannot have 3 electrons. In the first shell, only 2 electrons are present. 3 electrons are present in the second shell. And we are moving from the first shell to the second shell, then to the third shell, right? So this is the order of the shells. We cannot change that. We cannot change that. Is it understood?
Yes.
Fine. Hanji, carbon.
6, ma'am.
Six.
Which is 2 and 4. 4.
2 and 4. 2
2
by
and
4.
4, bache. 2 and 4, okay? 2 in the first shell, 4 in the second shell. Nitrogen.
7.
7. 2 and
2 and
5.
5.
Very good.
8, ma'am. Which is 2 and 6.
2 and 6.
2 and 6.
Good. Fluorine. Keep on writing fluorine.
9, ma'am.
Will be 9.
9.
Yes.
2
2
and
2
7.
and
2
7.
and 7.
2 and 7. Good. 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 Neon.
That will equal to 10.
10,
Huh.
ma'am. 2
Electronic
and
con-
EC equal to 2 and 8.
2 and 8.
2.
2 and 8.
Excellent. Excellent. All of you. Very well done. 11th is the sodium.
Z equal to 11.
11.
Uh-huh.
EC
Good.
equal to 2 and
2
9.
and
8.
9.
9.
9. The maximum capacity of the second shell is 8. 9.
2, 8 and 1, ma'am. 2, 8,
Sorry,
1.
8,
2
1,
and
ma'am.
1.
2, 8, 1.
2,
Sorry,
8, and
sorry,
1. No
sorry.
worries. No, sorry. This is the learning part. So 2, 8, and then we are moving on to the third shell here. That is 1 in the third shell, right?
Ma'am, so the third shell has a capacity of 18, right?
At your level, just take it as 8 because you are just concerned with the first 20 elements. Okay. If you are moving to the next set of the elements, that is from 21 to the subsequent elements, then we will be also including the 18 as the maximum capacity of the third shell. But as of now, it's just 8 for the first 20 elements. Okay.
Okay, ma'am.
Now, magnesium.
Z equal to 12. EC
12,
equal to
ma'am, which is
2
2, 8
and
and
9 and 2.
2,
2,
8.
8, and 2. Huh? 2,
Oh,
8 gives
sorry.
you 10 plus 2. No worries, no worries. Okay. That's it. Hanji, next one, Lokia will tell me. Aluminium. No one will answer.
Z equals to 13.
Just 1 second. sorry. So aluminium is 13, the atomic number is 13, but in the electronic configuration, look here.
2, 8, and 13. No, sorry.
13. 23 and 26. Good. 2, 8, and 3. Okay. Good. 14th is silicon.
Z equal to 4.
14
What? 14.
and 2, 8, 4.
2, 8.
4. Excellent. The next one is phosphorus.
Z equal to 1, 5. Electronic.
2, 8, 5.
So,
Excellent. 285. Next one only Mithun will tell me. So next one is sulfur. Mithun.
From Z is equal to 16, so it will be 2, 8, and 6.
2, 8, and 6. Now see 17. Yes, yes. Suleiman.
no, ma'am, I was asking for chance.
Acha, okay. Fine. Chlorine. Z is equal to 17. So electronic configuration will be. Go ahead, Suleiman.
Ma'am, yeah, ma'am. Yeah, EC equal to 2, 8,
Mm-hmm.
then comma 7.
Good. Excellent. 7. Okay. The next one, argon. Z is equal to 18.
EC
Electronic
equal to
configuration.
2, 2 and 8 and 8.
8. Excellent. Now next one, no one will answer. Okay. No one will answer. The 19th and the 20th. Method, first of all, what is the symbol for potassium?
Potassium is K1.
Just give me 1 second. Yes. Sorry for the disturbance. Yes. So potassium is K. The atomic number will be? Method, 19,
19, ma'am.
Just 1 second. I'm so sorry. Two, 8, and 9, Method. For this one, it will be 2, 8, and 9.
Yes, ma'am.
Yes. Suleiman, 2, 8, and 9.
Yeah, ma'am.
2, 8, and 9. Bethel, 2, 8, and 9.
No, ma'am. 2,
No, ma'am.
8,
2,
8,
8, 8, 1.
8, 8, 1. 8, 8,
Excellent.
8, 8, 1.
2, 8, 8, and 1. For 20th, which is calcium, the symbol is
CA.
CA, capital A or small a? Small. Good. Haji, the atomic number will be?
20.
The electronic configuration 2, 8, 8.
2.
Anyone, any problem here? Please let me know. So today we have completed this. In the next turn, we'll be starting the concept of valency. So please come after revising all of this because I will not revise this and then we'll start with the concept of valency. Okay? Everyone fine?
Yes.
Suleiman, you wait for just for a minute and then all of you can leave. Thank you.
Okay, ma'am. Bye, ma'am. Thank you.
Bye.
Bye, ma'am. Thank you.
Bye. Thank you. Bye. Suleiman, are you understanding all of this? Any problem? Any confusion?
No confusion.